You guys already know how to deal with first degree equations, which is your linear equations, your straight lines. And we also learned in chapter 8 how to deal with the parabolas, which is your quadratics. And so now what we're going to do is we're going to go one step further and learn how to deal with just a polynomial equation, whether it be first degree, second degree, third degree, fourth degree, fifth degree, whatever. So that's what a polynomial function would be. It's just a polynomial. Stuff that you learned in this book, it would be stuff that we see in chapter 3. And it's just taking those polynomial functions and we're going to graph them. We're going to solve them. That's about it. And then the rational functions, rational is just a fraction. Okay, so we're just going to take these rational functions and graph them as well. It's just graphing fractional equations. All right, so the first thing we're going to do is we're going to start off really basic. This is something that you should learn how to do in your basic Math 100 class or your basic Algebra 1 class back in high school, whichever your case may be. So if you remember how to do synthetic division, great. If you don't know how to do synthetic division or you don't remember how to do synthetic division, you can find this information in your book on page, starts on page 213, but really and truly we'll go to page 214. So on page 214 in your book, go ahead and look at that, page 214. If you don't know how to do synthetic division or you're kind of shaky on doing synthetic division, by the time we finish with chapter 9, you'll know how to do synthetic division in your sleep because we will do it so much. To use synthetic division, first and foremost, this can only be used if the leading coefficient of your divisor is 1. So, for example, on page 214, which ironically, the problem is listed on page 213, so I guess just go to page 213. The problem is 2x to the fourth plus x to the third minus 17x squared plus 13x plus 2 divided by x minus 2. X minus 2 is your divisor. What you're dividing with is your divisor, and what you're dividing into is your dividend. So, the leading coefficient of your divisor must be 1 in order to do this. So step number 1, what you're going to do is you're going to write the coefficients of your dividend. Do you remember which one that is? What you're dividing into. Write the coefficients of your dividend. If an exponent is missing, you've got to put a 0 in its place. Please don't forget to do this. This is huge. Don't forget to do that. If an exponent is missing, you've got to use a 0 as a placeholder. You've got to have those zeros. And then you're going to draw a sum bar. So, and I do it pretty much exactly how they do it in the book. My setup, if you go on page 214 and go about a fourth of the way down, on the right you see the numbers 1, 2, 3, 4. Look at number 1. Basically, you're just going to do a normal division bar. Just a normal division bar. Underneath the division bar is going to be your coefficients of your dividend. The coefficients of your dividend. Outside, that's step number 2. For the divisor, you're going to use the opposite of the constant so that we can add rather than subtract. Okay? So, when you do synthetic division, we throw out all the variables. And we use nothing but the coefficients. Nothing but the numbers. So that should make sense. So, step number 1, write the coefficients of your dividend underneath your division bar. Step number 2, write the opposite of the constant of your divisor. And then I just say draw a sum bar. Now, sum bar is the little bar, and you can put the addition sign out there if you want to. Then what you're going to do, step number 3, no math needed. So don't try to do math, because in step number 3, there is no math. You're just going to bring that very first coefficient straight down. Look at, look down in the middle of the page on page 214. You see how that first 2 underneath the division bar, see how they just brought it straight down? That's what you're going to do. You're just going to bring that first number straight down across that sum bar. And then what you're going to do is you're going to multiply the first coefficient that you just brought down times that divisor number. So look, you have in the middle of the page, negative 2 times 2 is negative 4, and you see they put that negative 4 underneath that next number. That's what you're going to do. Multiply the first coefficient of the dividend times the divisor, and add the product to the next term in the dividend. And then number 5, continue the process until all the numbers in the dividend are used. And then number 6, and this one for chapter 9 is extremely important. The last row is the quotient answer, and the last number in the answer is the remainder. That's huge. The last number in the answer is your remainder. All right, so let's see this in action. So for this very first problem here on the left, this is my dividend. That's what's going to go underneath the coefficients. Leave the variables out, okay? That's going to be your dividend, and here's your divisor. So we're going to draw a division bar, and we're going to take the opposite of the constant of the divisor. So I see a plus 2, so out here we're going to do a negative 2. And then underneath here, check your exponents, okay? Because if you're skipping an exponent, you've got to throw a 0 in there. So look, we're going from 4 to 2. So the third degree is missing. So we're going to hit 2, 0, negative 3. So now we have 4, 3, 2. Here's a 1. And then 0 is your negative 12. So your exponents, you have basically 2x to the 4th plus 0x to the 3rd minus 3x squared plus x minus 12. 4, 3, 2, 1, 0. And we're using the coefficients of each term. So 2, 0, negative 3, 1, negative 12. All right, the next thing you're going to do, draw your sum bar and drop that first number straight down, all the way across the sum bar. And this is where your math starts. Up until this point, it's just setting up the problem. So we're going to multiply negative 2 times 2, which is going to be negative 4, and we're going to put it underneath that next number, 0. And we're going to do exactly what it tells us to do here. We're going to add. So 0 and negative 4 is going to be negative 4. And we're going to continue this process until we get over here to this negative 12. So negative 2 times negative 4 is going to be 8. Put that under the negative 3 and add. Negative 3 and 8 is going to be 5. We're going to multiply negative 2 times 5 and get a negative 10. Negative 10 and 1 is going to be negative 9. Negative 2 times 9 is going to be 18. And then 18 and negative 12 is going to be 6. And I put a box around that one. And the reason being is because that's your remainder, okay? This is your remainder. So, what is my answer going to be? Well, watch this. I'm dividing an x out, which means my 4th degree polynomial is going to go to a 3rd degree polynomial because you're dividing an x out. So your 4th degree is going to go to a 3rd degree. And so this is what you're going to do. This is your first coefficient. This is your leading coefficient. 2 is your leading coefficient. So you're going to have 2x to the 3rd minus 4x squared plus 5x minus 9. And this is called your quotient. And your remainder is 6. So, on your test, that's what I'm going to ask you to do. I'm going to say divide, use synthetic division, divide, and then I'm going to have 2 blanks for your answer. I'm going to have a Q next to one, that's your quotient, and then an R next to the other one, and that's going to be your remainder. Okay? So, on the test, it'll look like this. Q with a blank and R with a blank. What do you think? Not so bad. Pure review. You've been doing this. Some of you have been doing this since 9th grade, 8th grade. All right. The problem on the right, this one, is the exact same thing. It's just written in fractional form, but it is a division problem. Okay, fractions are nothing more than a division problem. This long bar is your division. So technically, you could see this written as x to the 4th plus 256 divided by x minus 4. Okay, So if I wanted to see this written like this is how you would do it. And on your test, you could see it written either way. So just make sure you know which way, what to do with it, basically. All right, so let's set up in synthetic division. What goes on the outside? A positive 4. And on the inside? What's your first number? Your leading coefficient's what? 1. Then what? 0 is going to be x to the third. Next 0 is going to be x squared. Next 0 is going to be x. And then you have your 256. Good. So you have x to the fourth, 0x to the third, 0x squared, 0x, plus your 256. All right, so we're ready to go. Drop that 1 straight down. 4 times 1 is 4. Add them together and you're going to get 4. 4 times 4 is 16. Add them together and you're going to get 16. 4 times 16 is something. Yeah. And 64 and 0 is 64. And then 4 times 64 is that 256. All right, so what would the quotient be? And then your remainder, of course. There you go. Synthetic division. All right, so the next thing we're going to do is we're going to talk about a remainder theorem. And what we're going to do is we're going to build. Each section is going to build on the previous section. So as far as the remainder theorem and the factor theorems are concerned, we're going to talk about the remainder theorem first. The remainder theorem states that if the polynomial f of x, in other words, if your function is divided by a binomial, for example, this binomial would be x minus 1, then the remainder is equal to f at c, whatever you're plugging in. So, for example, if you have this function and you're trying to find f of 1 by using synthetic division, then you're going to check your answer using the remainder theorem. Watch this. If I plug in f of 1, I'm going to get 1 cubed plus 6 times 1 squared plus 5 times 1 minus 10. Do the math. Tell me what you get. I'm thinking 2. Because 1 cubed is 1 plus 1 squared is 1 6 plus 5 is going to be 12 minus 10 is going to be 2. Right? Watch this. What if you do synthetic division? Watch what happens. Drop the 1. Okay? So, and that's what the remainder theorem states. That if you can do synthetic division, whatever your remainder is, would be the exact same thing as if you plug, like what we did in chapter 8. If you plug c, which is your constant of your divisor, in and find f at c. You're going to get the exact same thing, okay? But this is what I need you to practice doing, all right? So if f of x is equal to this and it says find f of 1 by using synthetic division, then this is where it gets tricky, okay? If I say find f of 1, you're going to actually use 1. Don't take the opposite. If I give you a binomial, such as this, you have to take Okay? If I give you the number to use, I say use this number in synthetic division. Don't take the opposite. But if I ask you to do this using a binomial, you have to take the opposite. And the reason being is because of the formula. There's that minus sign. Okay? So, find f of 1 by using synthetic division. That's it. Your remainder's 2. Check your answer using the remainder theorem. Well, basically, the remainder theorem says whatever remainder you got should be the exact same thing as if you plug the number into the function itself. So, you can check to make sure you got it right. So, find f of c either by using synthetic division or evaluating. Actually, I want you to do both. I want to see if you can get the remainder and your evaluation to be. Alright, so again, going synthetic division, we'll have the 2, and then you have negative 4, 1, negative 2, 0, negative 5. Drop that negative 4 straight down. 2 times negative 4 is negative 8. Add them together, get negative 7. 2 times negative 7 is negative 14. Add them together and get negative 16. 2 times negative 16 is negative 32. Add them together and you get negative 32. And then when you multiply 2 times negative 32, you're going to get negative 64. Add those together and you do get negative 69. Which should be the exact same as if we plug 2 straight in. That is proving the remainder theorem. So if you type that straight into your calculator, you should come up with negative 69. If you're not coming up with negative 69 in your calculator, it's probably how you're plugging it in. Just be careful about that. Okay? So, let's look at the factor theorem. Remainder theorem basically states that if I give you C, not the binomial, but I give you C, that remainder is exactly equal to what you would get if you evaluated half C. The factor theorem, what are factors? What are factors? Things that you multiply together, right? For example, 2 times 3 is equal to 6. 2 and 3 are your factors. Things that you multiply together are factors. So the factor theorem states that a polynomial f of x, that's going to be your function, has a factor, something that you can multiply together, of x minus c, if and only if f of c is equal to 0. In other words, this is where the remainder theorem comes into play. X minus c is a factor if and only if you do synthetic division and your remainder comes out to be 0. If your remainder is 0, then it is a factor. Okay, and we're going to use this for the rest of the chapter. So you have to understand the factor theorem. You have to understand the factor theorem. So, I've already said that. You can determine this by either evaluating at C, as long as you know to take the opposite, because this time I am giving you a binomial. Okay? You can determine this either by evaluating at C or by using the synthetic division. I would suggest from this point forward we just use synthetic division. It can save us a little bit of time. So, for example, here's your question. Here's a perfect test question. Big, huge star next to this. It's a yes or no answer. Okay? Is x plus 1 a factor of 3x squared minus 5x minus 8? Now, those of us who know how to factor, you can factor this, yes, but I'm fixing to throw a third degree polynomial at you, okay? So you need to know how to do this. And again, your answer is either yes or no. Since I gave you a binomial factor, you have to take the opposite. So you're going to do a negative 1 into 3, negative 5, negative 8. Synthetic division, 1 times negative 1 times 3 is going to be a negative 3. Add them together and you're going to get negative 8. Negative 1 times negative 8 is positive 8, and you get a 0. Since I get a 0, the answer is yes. Therefore, watch this. This is so cool. You just learned another way of factoring a quadratic. Your answer for this, if I asked you to actually completely factor, which I'm about to do, if I asked you to completely factor this quadratic, it would be x plus 1, because I just proved that that was a factor. And the other factor would be 3x minus 8. How cool is that? So you now know another way. I don't know how many ways you know how to factor, but You now know another way to factor a quadratic. Use synthetic division. But you have to know one of the factors, or trial and error, which is something that we're going to do at the end of the chapter. All right, perfect test question. Is x minus 4 a factor of, and this is a third degree polynomial, is x minus 4 a factor of 2x to the third minus 11x squared plus 10x plus 8? So what's going to go on the outside of our synthetic division? Good. And what's going to go underneath?
2 minus 11 plus 10 plus 8.
And be careful. Make sure you're not, don't just blindly, I guess, write down coefficients. Make sure you're not missing exponents. Okay, I always check those exponents. 3, 2, 1, 0. Make sure you've got all those exponents. All right. First step, drop that 2 straight down. 4 times 2 is 8. Put the 8 underneath the negative 11. Add them together, and so we'll get negative 3. Multiply 4 times negative 3, and you're going to get negative 12. Add them together, and you're going to get a negative 2. 4 times negative 2 is negative 8. Add them together, and you get that 0, so your answer is yes. So, yes to what? X minus 4 is a factor. In fact, you can set it up as a multiplication problem at this point. You could have x minus 4 times what? Very good. 2x squared minus 3x minus 2. And then, since everybody in here knows how to factor a quadratic traditionally, you could continue the factorization, right? I hope so, because that's what we're leading up to. Y'all love to factor, right? Yay. That's what we're leading up to. All right, so that's the factor theorem. How do you understand? Don't kid yourself. Do you understand how to figure out whether or not a binomial is a factor of another polynomial? Just use the synthetic division and hope your remainder comes up to be 0. Your answer is either yes it is or no it's not. Okay? So, you can completely factor. This that we just did, this is not completely factored because we still have a quadratic that needs to be factored. This, however, right here, this is completely factored. Everything's in prime factorizations. Okay? You can't factor these anymore, so these are prime factorizations. That's how you know something's completely factored. This, however, is not completely factored because this is not a prime factorization. This will still factor. So, this is what we're going to do. You can completely factor a polynomial by using the factor theorem. First, use synthetic division to show that the factor that I'm going to give you, I am going to give you one of the factors, possibly. And that for this problem, it's going to be the x plus 1. So you're going to use synthetic division. You have to do this step or you can't go any farther to show that x minus c actually is a factor. Okay, so that's our first step. We're going to prove that this is a factor of this. So we'll have negative 1 into, we're not skipping any exponents, so we have 1, 6, negative 31, negative 36. Do the synthetic division, drop the 1 straight down. Negative 1 times 1 is going to be negative 1. Add them together and you're going to get 5. Negative 1 times 5 is going to be negative 5. Add them together and you're going to get a negative 36. Negative 36 times negative 1 is going to be a positive 36. And we just proved. So now this is what we have. We have x plus 1 is a factor, because I just proved that. X plus 1 is a factor. I just proved it by coming up with a 0 remainder. And my other factor that I have right now is x squared plus 5x minus 36. Bless you. But this is not completely factored. It's not completely factored because I have a quadratic here that's still factorable. Okay? So, watch this. This is very important. Since I have a third degree polynomial that I'm trying to factor, I know it's a third degree polynomial because that's the highest degree term. Since I have a third degree polynomial term or polynomial that I'm trying to factor, how many factors should you expect? 3. If you have a second degree, 2. If you have a fourth degree, 4. Okay? So we're expecting 3 factors. Right now, how many do I have?
2.
Just 2. Just 2 factors. So, this is 1. And let's see if we can figure out what these other 2 are going to be. X squared plus 5x minus 36. For those of you who are factoring whiz, do you know what it's going to be already? Very good. For those of you who do not understand where that came from, take a visit back to chapter 3. Take a visit back to the last part of chapter 3, and it'll tell you how to factor this. In particular, 3.6. 3.6 shows you how to factor these trinomials. And you just completely factored a third degree polynomial. What do you think? Do you see how everything builds on it? You got to know how to do that synthetic division. Then you got to understand the remainder theorem. Then you got to understand the factor theorem. And then you got to know how to completely factor. Okay? You know what the next step is? Well, we could do a fourth degree, but not right now. Let's try this again. No. Let's try this again. Show that g of x is a factor, first of all. First of all, you got to show that g of x is a factor of f of x, and then complete the factorization. So your first step is to set up your synthetic division. All right. And don't take that for granted, okay? If you don't come up with a 0 right here, then you're probably a mistake on my part, because you should come up with a 0, because that's the whole point. But on your test, if you come up with a 0 right here, or if you don't come up with a 0 right here, it's not factorable. Okay? Well, you just proved that x minus 3 is not a factor. I won't say it's not factorable. Alright, so this is what we have now. We have x minus 3 as a factor. And then we have 6x squared plus x minus 2. And so we need to factor that. Does anybody know the factors? Yep, you got it. Alright, so again, factoring trinomials. Do we need to do a mini lesson on factoring trinomials? If you need a little bit of help of factoring these trinomials, come see me in our off time, and I'll be more than happy to do a mini lesson with you. I do have my Math 100 lesson for factoring. Do you want me to upload that into Blackboard? Or are we okay with factoring? Okay. Like I said, if you need help, just let me know. So, completely factor. This is how you're going to do it. Alright, so the next thing we're going to do is polynomial equations. So, I don't think it's page 464 anymore. It's something that we've already talked about anyway. It's page 488. about this. If you have a linear equation, look at that green chart in the middle of page 488. If you have a first degree equation, you should expect one answer or one factor. Quadratic, you should expect 2. Third degree, you should expect 3. Fourth degree, and so on and so forth. Now, sometimes factors can repeat themselves, and when they do repeat themselves, it's called a multiplicity factor. And when you have multiplicity factors, your graphs do crazy things, because we are going to end up graphing these. I'll just go ahead and tell you, Math 1 sub is a lot of graphing. Grin and bear it. But it does have a multiplicity factor, so we'll see some that are like that. Don't worry about that. But what we're going to do is we're going to take these equations and we're going to solve them. So, building blocks again. We went from synthetic division, and then we used that synthetic division to do the remainder theorem and the factor theorem. And then we used both of those to completely factor polynomials. So now what we're going to do is we're going to take these polynomials, set them equal to 0. Do you remember how to use the zero product property? Once you have all these factors set equal to 0, how do you continue to solve? Yeah, you take each. In other words, if I had and I asked you to solve, what would you do? So here x would be and that's our goal. That is our complete and total goal. Okay? So, rational root theorem. Finding rational solutions. And it's not page 465. It is page 489. States that for any polynomial equation, if C over D, which somebody said, I think it's P over Q, this is where the P over Q comes into play. If you learned it as P's over Q's, it's the exact same thing. We just use C over D. Rational root theorem states that for any polynomial equation, if C over D is a solution to the equation, then C is a factor of your constant, and D is a factor of your leading coefficient. So D is your leading coefficient, and C is your constant. Okay, therefore, here are your steps. And there are shortcuts in here, so once you get used to doing this, you'll find those shortcuts and you can go with those, okay? To find the rational solutions to a polynomial equation, in other words, to solve one of these things, what you're going to do is you're going to find factors of C and D, things that you can multiply together to get your constant and your leading coefficient. And then what you're going to do is you're going to find all possible values for your factors of C over your factors of D. And then you're going to use your factor theorem like what we were just doing, beginning with your whole numbers. And that the reason being is because the ones that I'm going to give you are going to have whole number factors. So if you go through all your whole numbers and none of them worked, you've done something wrong. Just a big hint. I'm not going to give you fractional factors initially. Alright, and then step number 4, continue until a second or first degree polynomial is left, and then factor the remaining polynomial, and then solve. So, example, solve this polynomial equation. Find the zeros is in parentheses. We've already talked about that. If I ask you to find the zeros or solve one of these equations, what am I asking you to find?
X-intercept.
Your x-intercept. Somebody was listening. Hallelujah. If I ask you to find the zeros or solve one of these polynomial equations, you are actually finding your x-intercepts of the graph. Okay? You are actually finding your x-intercepts. What happens if you come up with imaginary numbers? We talked about this in chapter 8. There's not an intercept for those imaginary numbers, right? But they are solutions. Okay, so find the zeros. First of all, what is C going to be? -4. And what is D going to be? 1. Okay? So, this sign is really going to be irrelevant. What I want to do is I want to find factors of 4. Can you tell them to me? Right? And the reason why I said that sign is irrelevant is because we're going to do both plus and minus of each of these. What are the factors of D? Or factors of 1? It's your leading coefficient. And C is your constant. Okay, so if I need to find C over D, what's that going to look like? One over 1, 2 over 1, and 4 over 1, not 3, 4 over 1. Or just simply plus or minus 1, plus or minus 2, plus or minus 4. Now when does that change? It changes when your leading coefficient is not 1. When your leading coefficient is 1, it's easy. You're just looking at C. When your leading coefficient has factors aside from 1, that's when you get into fractional solutions. Okay? So I will just go ahead and tell you, these 6 numbers, plus or minus 1, plus or minus 2, plus or minus 4, those 6 numbers are possible solutions to your equation. Possible solutions to your equation. So, what are you going to do? Well, look at our notes. Find factors of C and D. We did that. Find all possible values for C over D. We did that. That's here. Then what you're going to do is you're going to use the factor theorem, beginning with the whole numbers to find a factor. So, we're basically going to do synthetic division. Just to save a little bit of time, I'm going to divide y'all up, okay? So, this row, y'all try 1 in your synthetic division. Y'all try negative 1. Y'all try 2. Y'all try negative 2. And you guys try 4. What you're doing is you're doing synthetic division with a number that I assigned you, and you're trying to come up with zeros. Now, did I give you a number or did I give you a binomial? A number, so you should know what to do with that. So they tried 2, and our polynomial is 1, 1, negative 4, negative 4. Alright, so if we drop the 1 down, 2 times 1 is 2, add them together and you're going to get 3, 2 times 3 is 6. Add them together and you're going to get 2, 2 times 2 is 4, and you do get 0, so that's good. So, what is your first factor that we just found? When you put it back in binomial form, you have to take the opposite, remember? So it's going to be x minus 2. And then what's the other one? You see where that came from? Came from right here. We started with a 3rd degree polynomial, but we divided an x out, so this is going to be x squared plus 3x plus 2. Alright, let's finish the factorization. Completely factor this. What's it going to go into? X plus 2 and x plus 1, right? Why can you multiply together to get 2, but add together to get 3? Gentlemen. But it's still equal to 0, so now we have an equation, so we have one more step, and that's use that zero product property. So we're going to get x is equal to 2. You already knew that. X is equal to negative 2, and x is equal to negative 1. So those of you who had negative 1, this row, did y'all get a 0? And for those of you who had negative 2, did y'all get a 0? So, all possible solutions. If you don't hit one, hopefully you'll hit another one. Okay? But we're gonna hit whole number solutions. And once we use those whole number solutions, then we'll find the fractional solutions if need be. Okay? Questions? This is craziness. This is craziness. Let's try